Okay, we will start our lesson with a revision about energy transfer. Can you give me way of transferring energy?
Heat,
No, a way. How can the energy be transferred? Like,
Burning, by burning?
no, the energy itself. Like when you burn, how can you get the energy? How can you feel the heat? When you burn some iron, piece of iron on fire, when you put it on fire, how can you get the energy from one end to your hand? By what?
touching,
What?
Heat transfer?
Okay, heat transfer by what?
Conductor?
Conduction. Conduction is a way of energy transfer, thermal energy transfer in solids, okay? This way, by vibrating the atoms, the atoms or the particles of the solid, okay? When they vibrate, they will transfer the energy to each other until it gets to your hand, okay? What about the liquids? Which way? You didn't study the previous lessons.
I did just yesterday.
Okay, what do we call the energy transfer way in liquids?
It's not evaporation, is it?
No, of course not. It's by convection, okay? Convection. This is a way of transferring heat or thermal energy in liquids. Convection is, you know, why we are placing the air conditions up, okay, and placing the heater down on the floor. Have you thought about this?
Because the warm air rises up and the cold air sinks down.
Yeah, this is the convection, okay? When you place the heater down, okay, the down layer in the room is cold, so it will be heated by the heater. It will get lighter and transfer up to the upper layers, and the colder one or cooler one will get down, and it will be in circle. It will be circle all over the room. So this is called convection, okay? Today we will study about energy transfer in gases, okay? This is called radiation. Why do we have radiation? Radiation is important to get the sun energy to the earth or to any planet, okay? Without the sun, we will die because there's no heat, there's no thermal energy, there's nothing, okay? So energy transfer by radiation, why and how do you feel the sun heat? When you stand under the sun, you will feel the heat of the sun, right?
Yes.
How do we feel this? How do we feel this exactly? This is because of the radiation. Thermal radiation, or we call it infrared radiation or infrared. This is the radiation comes from the sun. We all heard about something called infrared, right?
Yes.
What?
Infrared.
No.
Infrared is a radiation comes from the sun. Actually, they were using it in phones, old phones. Okay.
It's a part of the electromagnetic spectrum.
Oh, this is your major. Okay.
Yes.
Thermal radiation or infrared radiation, even they were using this infrared in old phones. They were transferring informations or data by using infrared. They were like having a small patch like on the side, one side of the phone, but in this way they need to use the phones and they need to keep the phones next to each other, like very closely to transfer. It's like something like Bluetooth, okay? So this is infrared, but the infrared radiation comes from the sun. That's what gives you the heat of the sun. And this depends on the temperature of the object. So, for example, if we have the heater away from us and the heater next to us, okay, which distance we will feel the heat more?
Closer to us.
And that is further.
The one near us.
Yeah, close to us or near to us, because radiation is transferring very closely to us. Okay, let's say if we have weak heater and strong heater and they are on the same distance from us, okay? Which one of them we will feel the heat from it?
The strong one.
The strong one. Why?
Because it gives out more heat.
Yeah, this is the reason. It gives out more radiation because the temperature is higher. So as more as you get high temperature, more radiation you will get. For example, we can see in winter, okay? No, let's say not winter. Okay, very hot days, okay, we will get more radiation, okay, more radiation, because that's how we can feel like very hot days other than the cooler days. So depending on the temperature, you will get radiation. If it's high, you will get high radiation, you will feel more heat or more energy, thermal energy. If it's low, you will feel less thermal energy. Radiation is the emission or transmission of the energy in the form of waves of particles through space or medium. Guys, can you remind me how can how can we get the sunlight, okay, and even we don't have any air or the space is a vacuum. So why we can get the sunlight or the thermal energy? It's an energy, it's light. How can we get it and the space has no air? It's a vacuum, like space is a vacuum.
Because
of the
light can
nuclear.
travel in vacuum.
Yeah, so Fatima, did you say something?
Yeah,
Okay, you said what?
I said because of the. I don't know. I'm not sure of it.
Okay, just say it.
Is it because of the nuclear that is inside the sun? Because it's strong enough.
Nuclear fusion, you said, you mean?
Yeah.
Okay, Mohammed, any ideas?
What?
Any ideas about this?
No.
Why do we get light from the sun? And
Because
how?
the light can travel in vacuum. It doesn't need
Yes.
it doesn't need something to travel on.
That's good, Sophie. Light doesn't need a medium, like a sound. We cannot hear anything in space, but we can feel the sunlight. So light doesn't need any vacuum, any medium to travel through. So the radiation can travel through a vacuum. Infrared travels as a wave. It's like a light wave. This is the infrared even, which is the thermal energy, can travel as a wave. It has a wavelength, it has a frequency, it has a frequency and wavelength. So it can travel, and it can travel as a wave. And it can be reflected and transmitted and absorbed. So we can absorb sunlight by our bodies. Our skin can detect infrared radiation. That's how we can feel hot under the sun. That's how can your body alert and excrete sweat. So in this case, your body temperature is increasing, so your body needs to sweat, okay? So radiation and absorb the radiation that all objects emit depends on temperature. The objects that emit radiation, all of them depends on the temperature of the object. Let's say a hot cup of tea, okay, next to us, and cold one, like normal one. Which one of them you will feel the heat comes from it?
The
The hot
coffee.
one.
Coffee.
The hot one, okay? So we have 2 cups. One of them is hot. This is hot. And this is cold. Cool, let's say cool, okay? So this one, we will feel the energy comes from it more. Why? Because the temperature is high. But the temperature here is low, so we cannot feel the radiation that comes from it. Since it's normal temperature, it's like, let's say 25 degrees, still we cannot feel it because here the radiation comes from it more and more. Is it clear?
Yes.
Yes.
Okay. How can the energy transfer? Thermal energy can be transferred by conduction and convection. And we said conduction in what? And convection in what?
In solids and convection.
In solids,
In liquid.
conduction.
Yeah,
Convection.
convection in liquids, good. Infrared radiation is another way that thermal energy can be transferred. Radiation doesn't need a medium for the thermal energy to be transferred like the sun energy. So, okay, this is the transferring. So how can the energy or the radiation be reflected, okay? I have here some questions. Okay, we use foil to cover hot food. Why, if we want to keep the food or the dish warm or hot, we need to cover it with the foil?
Because it conducts
You have to trap all
heat.
the heat.
No, it's not conduct. No,
traps.
not conduct.
Yeah, it doesn't let any of the heat go out. Like it
traps
keeps
it.
it inside.
Okay,
Yes, it traps it.
How can we trap it inside? Okay, we can use like we can use normal papers. Why we don't use normal papers, for example? Why?
Does it have to do something with the structure of the foil?
Okay. What's happening exactly inside? How can we trap it? We are reflecting the radiation. The radiation comes from the food, the hot food, is reflected by the foil. So if the dish is hot and we need to cover it, the radiation comes up and go back down. So in this case, the radiation, the temperature will be warm. It will not escape. The radiation will not escape. So the dish will keep the heat inside or the energy inside. Is it clear?
Yes.
Okay. We have the marathon runners. You might notice that the marathon runners cover their bodies with foil sheets. Why? What's the difference between a runner and someone is sitting down?
Can you repeat this, please?
Marathon runners, after finishing their race, okay, they need to cover their bodies with the foil sheets, thin foil sheets, the one that we are using for first aid, you know, I showed you once. Okay.
Yes.
Yeah, they are covering their bodies with foil sheets. Why they're using this? What's the difference? Like, I can cover myself with the foil sheet, but he needs it more than me. Why?
Like to not let their body heat go out.
Yeah, good. When their temperature is getting higher, okay, while running, the body temperature is increasing, right?
Yes.
Because of the circulatory system, okay, and the heartbeat, so the temperature will rise. So when the temperature will rise, they will start to emit, like send radiation, okay, from their bodies. If they start to emit this radiation, they will lose temperature, right? And they might die because their body temperature will decrease. So what they are doing, they are covering their bodies with the foil sheet. It's like the idea of the dish, okay? So if their body gets higher, they will start to emit radiation all over, okay? So if they covered with the foil,
Will reflect.
if they covered themselves with the foil, the radiation will hit the foil and go back to their bodies. In this case, they will keep their body temperature stable. Is it clear?
Yes.
Guys, all of you?
Yes.
Yes.
Okay. In case
Yes.
of hypothermia, what is hypothermia?
It is when your body temperature goes very low.
Yeah, when your body temperature decreases too much. You know, like the drowning cases in ice lake, frozen lake. This is hypothermia. When they came out of the lake, when they come out from the lake, their body temperature will be very low. So paramedics, which are the people that save in the ambulance, they call them paramedics.
Yeah.
They use foil sheets. This is as a first aid to cover the casualty, which is the person. Okay, they cover them with the foil sheets. In this case, they will not lose their body temperature, what's left from them. So the body temperature will reflect like the marathon, okay, to keep them warm. In this case, they need to cover them with the foil sheet. So we need to reflect the radiation by using foil. Okay, what about the earth? We will come to this next later, but I need you to give me an idea about how can the energy that gets into earth be reflected?
By water?
By water and land. When we go to the beach, we can feel the heat comes from the ground, from the sand, right? Hello, it's summer.
Yeah.
Yes.
All go to the beach. Okay, you can feel the radiation comes from the sand and comes from the water if you are inside, but the water keeps you cool, kind of. Okay, so this is how can the energy or the radiation reflected by the earth. Okay, we still have the greenhouse effect. We will explain more about how can we reflect back the heat or the thermal energy, so we will not lose the temperature that we get from the sun. Okay, even the radiation can be absorbed, as we said. Thermal imaging cameras or normal cameras and your skin also can absorb infrared. We all know the radiation, the thermal imaging cameras that we can picture or we can catch the thermal energy of the body, the one that they are using now for the coronavirus to detect the body temperature. These are thermal imaging cameras. Okay? How do they work? Actually, they are absorbing the infrared. This is the camera, okay? They are absorbing infrared inside. It's like the normal cameras, but the normal camera can absorb the light around it. Only the light, not the thermal energy. Okay, but the thermal imaging cameras, they call them thermal because they are absorbing thermal energy. They are absorbing thermal energy inside. In this case, they will detect the body temperature for humans, okay? Okay, and what about your skin? We said if you stand under this under the sun, if you're standing under the sun, after 1 or 2 minutes, you will feel your skin is getting warmer. If you are feeling cold in winter, you will go out to the garden or to the backyard, you will sit under the sun, so your body temperature will increase. How your body temperature is increasing?
By absorbing thermal energy.
Yeah, it absorbs the infrared radiation.
Infrared radiation. It absorbs infrared radiation, so your body temperature will increase because your skin is detecting this infrared. Okay. Let's go to the next page. Dull dark surfaces tend to absorb more radiation than shiny light ones. Have you ever noticed if you hang clothes, dark clothes on outside, okay, and they were wet, they will be very hot, dry after drying, okay, they will be hot more than the light shiny ones. Why?
Yes. It's because
Because
the
they,
dark colors,
because
they absorb more light.
Yeah, they absorb more light, though they will absorb more infrared radiation from the sun. Okay, so dark colors can absorb light more and infrared more. So that's why in summer, we don't wear dark colors. We need to wear shiny light colors to reflect the sun energy, the thermal energy. We are saying that we are reflecting light. We are reflecting the thermal energy more because they can absorb less thermal energy than the dark ones. Is it clear?
Yes.
yes,
Okay,
Yes.
let's see how the energy balance on Earth. We said that when the energy is, okay, let's say this is the Earth, okay? Around the Earth, what do we have? Around it.
We
ozone
have
layer.
atmosphere levels, like
Atmosphere. What do we have in this atmosphere?
we have the levels of it in the ozone layer.
No, I mean like this atmosphere composed of what?
Gases.
Gases. What do we call these gases? Muhammad.
Greenhouse gases.
Yeah, that's good. Greenhouse gases. Okay. Why do we have these greenhouse gases? We studied this before. In air pollution.
Yeah, because the gases,
They
come
come
when we
from
burn.
like the things that we burn and the materials that we use.
No, I'm not talking about this. They don't come from this, no. They are making the global warming worse, but they are, we have them already. Can you remember what are the greenhouse gases?
Carbon
Carbon
dioxide.
dioxide.
Carbon dioxide and?
Good morning, Miss Hannah.
Good morning, how are you?
Hi, I'm fine.
Naeem, can you tell me what are the greenhouse gases?
Carbon,
Carbon is
carbon dioxide,
yeah, carbon dioxide and?
sulfur dioxide.
No. This is a pollutant gas. Guys, methane. We mentioned that before, methane. And also we have water vapor. Water vapor, we can feel it, which is the humidity, right?
Yes.
Yeah, these are the greenhouse gases. The greenhouse gases keep the radiation inside. We said that when you increase the level of carbon dioxide, especially, this will get the earth warmer, right?
Yes.
Why it gets warmer by increasing carbon dioxide?
Because it will be trapped.
They will be trapped, the heat will be trapped, or the thermal energy or the radiation energy will be trapped inside the atmosphere. Okay, how it can be trapped inside? By what? By reflection, okay? By reflection. CO2 or greenhouse gases, they can reflect the radiation back to Earth. It's like the foil sheet. Let's imagine the atmosphere is the foil sheet around the Earth. It's like the foil sheet around the marathon race runners. okay? So each time, if you have a radiation comes from the sun, okay, it will get, the earth will get hot and it will reflect back out, the radiation back. Okay, it's
لا لا
reflecting the radiation back. In this case, we will lose the temperature. This atmosphere with its gases keeps the radiation inside. Let's say retransmitted or re-emitted. What does it mean? Like what do we mean by emit? Emit energy.
Absorb.
What?
Absorb.
No, not absorb. Emit means like send, okay? So when the radiation comes from the sun, okay, it will be reflected by oceans and lands back to the atmosphere. The atmosphere will re-emit
Reflected
it
back?
back, which is reflected back to the earth. In this case, the earth will stay warmer or will stay warm. We will not lose the temperature. We will not lose the radiation or the heat on earth. Without this atmosphere, the earth will be very, very cold at night and very, very hot during the daytime. In this case, we cannot live on earth like the other planets. Okay, so is it clear this point?
Yeah.
Okay, the atmosphere reflects, the sun transfers energy on the earth by radiation, such as light and infrared. The earth's atmosphere reflects some of this radiation, about 50% of it is absorbed by the land and ocean. So 50% of this radiation is absorbed and the other 50 is reflected, okay? The earth emits infrared and some of that is reflected back to the atmosphere. So it will emit it and it will be reflected. The rest is transmitted through the atmosphere into space. So is it back?
Yes.
Okay, so about 50% absorb, the other will be transmit to the atmosphere and out to the space. In this case, the earth will not get too much heat, so it will not be so hot, the temperature will not increase too much. The earth's temperature depends on the balance between the radiation that is absorbed and that is emitted. So if we have more absorbed than less emitted, in this case, the temperature will increase. That's how the global warming now is affecting the earth too much. These gases, when they increased in the atmosphere, they started to absorb more and reflect back more radiation to earth, so the temperature is increasing each time. The atmosphere reflects radiation because it contains greenhouse gases such as CO2, methane, and water vapor. Okay, I will show you now, show you now a video about the radiation and the greenhouse effect, okay?
The greenhouse effect. When you see a beautiful, fat, full moon, do you ever imagine what it'd be like to be up there, standing on its surface? Well, for one thing, hot. About 120 degrees Celsius hot. But 14 days later, new moon, you'd be in the middle of the long lunar night, and the temperature would have plummeted to around minus 170 degrees. On average, the moon and Earth are the same distance from the sun, so they get the same amount of solar energy. But here, the average temperature is 16 degrees Celsius, while on the moon, it's more like minus 80. The Earth has a much smaller range of temperatures too. Minus 88 and plus 57 are the lowest and highest on record. So, why the difference? The answer is the atmosphere. It protects us from a lot of the sun's energy, but also traps some that gets through so that, for example, at night, temperatures don't fall that much, especially if it's cloudy. The energy that comes from the sun is electromagnetic radiation in a broad range of wavelengths. The upper atmosphere absorbs most of these wavelengths. Visible light gets through, but a third of this reflects straight back out again, mainly off clouds and ice. But only half of the energy heading for Earth gets to warm its land and oceans. Rock, soil, and water heated by visible light re-emit the energy as low-energy infrared radiation, heat. This can pass through the oxygen and nitrogen in the air. But some gases, the so-called greenhouse gases, carbon dioxide, methane, nitrous oxide, and water vapor, have molecules with structures that make them absorb the radiation. Struck by an infrared wave, they vibrate strongly before releasing the energy as a new infrared wave. This can shoot out in any direction, towards space, down to Earth, or out sideways. But in every case, there's a good chance the wave will strike another greenhouse gas molecule and change course again. Although greenhouse...
Guys, did you see this? The radiation comes from the sun. Guys, are you there?
Yes.
Okay, and emitted by the Earth. Okay, when the Earth emits these radiation, they will hit these molecules. These molecules for CO2. This is CO2, the red and gray one. This is CO2, and we have methane, and we have water, which is H2O. Okay, the two blue and one red. This is H2O, and the gray with the white dots, this is the water, this is methane, okay? So when it hits, the radiation hits these molecules will vibrate and send it again, okay? They will send it back again. So when they send it back again, it will be sent to the Earth. So let's watch and continue the video.
They're in a layer of atmosphere 6 kilometers deep. Not much escaping radiation makes it through without encountering at least one greenhouse gas molecule. Over the entire planet, the result of this giant pinball game is that heat stays close to the Earth's surface for longer than it otherwise would, keeping it warmer. This is the greenhouse effect.
So, did you understand it?
Yes, I got it.
Okay, the last thing about the magnetic spectrum. We said that radiation have wavelengths and frequencies, right? This infrared radiation is a spectrum of it's a wave of electromagnetic spectrum. You know, like light, we have a spectrum. We have green, we have blue, we have red, we have violet, different colors, because they have different wavelengths. The same with these infrared, with this radiation. This radiation is are waves of the electromagnetic spectrum. Since they have different wavelengths, different wavelengths, they will be different in uses, and some of them will be endangered. Okay, have you heard of gamma rays or gamma?
Yes,
Gamma ray
it's the most dangerous one.
Yeah, it's dangerous. It's dangerous because it has the shortest wavelengths and very high frequency and very high energy. And the lowest one is radio. The radio one has long wavelengths and low frequency, small energy. That's why it's less harm. So the range of radiation with electrical and magnetic properties that can travel through vacuum. This is the electromagnetic spectrum, the definition of electromagnetic spectrum. Light and infrared are parts of electromagnetic spectrum. Parts of electromagnetic spectrum travel at the speed of light. That's why we can get it immediately to Earth. They have different wavelengths, frequencies, and energies. They all have different uses, and some are more dangerous than others. Guys, I need you to solve the yellow box, and I need you to find the uses of these rays. Let's say the gamma rays or the radio. You have it in the book. We have infrared, microwaves, we have visible light, we have ultraviolet. I just need you to find me to find one usage of each one of them. Okay?
Okay.
Okay. So see you next time. Bye bye.
Okay.
Goodbye.
See you. Goodbye.
Bye.